Here we have the first of these difference equations. So there will be a little pattern that we'll follow here. We're told that un is equal to this. We're told that u0 is equal to this, and we're asked to find the limit as n approaches infinity of un. So what we do first is we let n equal 1 to get u1 here. Therefore u1 is equal to a half of un minus 1, so u0 plus 1. So that's u1. We'll go all the way to 3 here. When n is equal to 2, we'll be able to get u2, which is equal to a half. Again, from up here, it's going to be a half of, if n is 2, it'll be a half of u1 plus 1. And u1 is this guy here. So u2 then becomes a half of u1, which is, I'll put it in a bracket, half of u0 plus 1. And we'll have to bring in this one as well, don't forget. And if we multiply this out, u2 becomes, well, because we want to see the pattern here, becomes a half squared by u0. This one by this one. Then it becomes a half by 1. I know that the 1 is not necessary, but I'm going to put it in. And then we have this 1 as well. On to when n is equal to 3, we'll get u3, and then we'll see what un is. When n is equal to 3, u3 becomes a half of u2 plus 1. And that's equal to, we know what u2 is, a half of, this whole expression here is u2. So it's a half of a half squared times u0 plus a half times 1 plus 1. That's u2 and then plus 1. If I multiply this out, we'll see the pattern. That's equal to a half to be cubed by u0 plus a half, this half by this one in here, a half to be squared. Now the 3 is n, the 2 will be n minus 1 by 1. We don't need the 1 plus a half by 1, and then this 1 at the end. So what we have is we have this expression here, and this is a geometric progression here. So if we just move across to the side, we're going to get, therefore un is equal to, well, u3 was this guy here, so un will be a half to the power of n by u0. And then separately down here, I'm just going to make this, what is this? What is Sn of this? Well, a is equal to, if we reverse it around, we're going to have 1 plus a half squared, and so on. That's going to keep on going to a half to the power of n minus 1. Position 3 we have 2, so the last position will be n minus 1. So a is equal to 1 and r is equal to a half. So Sn is equal to a times 1 minus r to the power of n inside there over 1 minus r, which is equal to the 1 in front, by 1 minus a half to the power of n, all divided by 1 minus r, which is 1 minus a half. Now the bottom becomes a half, so we're going to get 1 times 1 minus 1 over 2. This can be done a little bit quicker, but I'm just doing it in long form for this first video, over a half. And if we divide something by a half, we turn it upside down and multiply, so it becomes like 2 over 1. So the bracket on top becomes 2 times 1 minus 1 over 2 to the power of n, which is 2 minus twice 1 over 2 to the power of n. So this kind of thing is the key to these questions. So un therefore becomes this guy plus the guy that we just figured out, 2 minus 2 times 1 over 2 to the power of n, and we have u0 in the question here, it's 100. So we have 100 1 over 2 to the power of n's minus 2 1 over 2 to the power of n's plus 2, which becomes 98 1 over 2 to the power of n's plus 2. And we're asked find the limit as n approaches infinity. Now if n approaches infinity, 1 over 2 to the power of n. You can imagine 1 over a million is going to be a tiny number. It's going to get bigger and bigger on the bottom, so therefore this approaches 0. So therefore, as n tends to infinity, un tends to the number 2, because this whole expression will be equal to 0, 98 times 0. So that's how these are done each time. They get a little bit tricky, but practice them to get good, and then these questions will hold no fear.